All right, we're back. We're talking about section 6.2. That's the law of cosines this time. So I'm going to try to make this a much shorter video than the last one, the law of sines. Law of cosines is a little more straightforward, I think. We don't have to worry about an ambiguous case here. Now, the two cases where we use the law of cosines are when we're given 3 side lengths, or when we're given 2 side lengths and the included angle, the angle in between them. So if I'm given either one of these cases, there's no way for me to set up the law of sines. I can't set up my ratios, a over the sine of a equals b over the sine of b equals c over the sine of c. Those won't help me. Given the information that I have, SSS or SAS, side, 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 or side, angle, side, I can't do anything with the law of sines. I'm still stuck. So we turn to what we call the law of cosines. So we'll talk about where the law of cosines comes from in class. It's pretty straightforward. It's a lot of algebra and some trig. But basically, they're new formulas for us to use. So this is what we call the standard form of the law of cosines. This is what's on your district formula sheet. There's also the alternate form, which is the same thing, except we solved for the cosine of A, B, or C, just using some algebra. That is not on your district formula sheet. So it's not really something you need to memorize, just something you need to be able to solve for here, like solve for this cosine here. And same ABC that we were using before. Capitals are for the angle measures, and then lower cases are for the side lengths. And it's another formula for us to plug into to help solve for the solve the triangle, solve an oblique triangle. So let's look at the first case here for the law of cosines. If I'm given 3 side lengths, then I obviously need to start by finding an angle. So if I'm solving for an angle, I'm probably going to want to use the alternate form, because here I've already solved for the cosine of A, B, or C. Now, as we can see, the law of cosines, these forms, these formulas, are a little more difficult to use than the law of sines was. So not that it's hard, but it's a lot more to plug in and to keep track of in your calculator. So we're going to try to find an angle first, and then we can either use another law of cosines form to find another angle, or we could use the law of sines. So I'm going to go through example number 1 here, and I'm going to just use the law of cosines twice since it's new, so we can see what we're doing. So given the 3 side lengths, find the remaining angles and sides. Well, in this case, there are no other side lengths, so I need to find the 3 angle measures. I'm going to say always find angle A first. Just as a general rule, it helps us keep track of things a little more easily. So let's draw the triangle A, B, C. So A is 8, B is 19, C is 14. And I need to solve for some angles. So I'm going to use the alternate form here. Let's solve for angle A first. So the cosine of A equals B squared plus C squared minus A squared all over 2BC. So they gave me A, B, and C here. All we have to do is plug in. So B squared plus C squared minus A squared all over 2 times B times C. So I'm going to plug all of this into my calculator, and then that equals the cosine of A. So to solve for A, I'm going to take the inverse cosine. So I get A is about 22.08 degrees. Now, from here, I could either set up the law of sines, do 8 over the sine of 22.08 equals 19 over the sine of B, or I could keep using the law of cosines to solve for B. Both options are perfectly fine. Both options give you the same answer. So I'm going to use the law of cosines again, even though it's a little longer. It's a little more straightforward. You're just plugging into a formula, and it's new, so I want you to see another example of it. But regardless, whichever method is easier for you, by all means, use it. So the cosine of B equals A squared plus C squared minus B squared all over 2 times A times C. So plug this into your calculator, then take the inverse cosine to solve for the angle measure, and we get B is about 116.80 degrees. So C, I could either use the last form, cosine of C, and solve directly, or I just know that C is going to be 180 degrees minus A plus B. So 41.12 degrees. And then it is helpful, especially when I'm grading these, if you consolidate all of your answers in one place. That'll make my life a lot easier, please. Thank you. So that's basically it. Given three sides, that's all we have to do. There's a lot of different options I hope you're noticing when we're solving oblique triangles, especially now that we have both the law of sines and the law of cosines at our disposal. There are a lot of situations where I can start with the law of cosines, finish with the law of sines, or knowing that all my angles add to 180 degrees, take that shortcut, or just use the law of cosines for all of them. Um, it really just depends on what you remember, what you're comfortable with. And that also means there's a lot of different ways to check your answers. Okay. So go ahead and try example 2 on your own. And I'm going to go through example 3. I'm going to have you try example 4 on your own. Now, that was for side, when I'm given 3 side lengths. The other case where we use the law of cosines is when I'm given 2 sides in the included angle, side, right here. This is still pretty straightforward, I think, not any more difficult. We do have to start by using the law of cosines. We're going to start by finding the missing side length. So we have a ratio from the law of sines complete for us to use. And we'll see what I mean by that. So example number 3, given A equals 115 degrees, B equals 15 centimeters, and C equals 10 centimeters, find the remaining angles and sides. Let's draw this. A is 115 degrees, so that's an obtuse angle. And then B is 15 centimeters, C is 10 centimeters, and I don't know A. So just by looking at this triangle, that's why I tell you to draw it, I know I have I have a side length, another side length, and the included angle, the angle between them. So this is side angle side. And I need to find A here. Because as it is right now, I can't set up the law of sines here, right? I need a side over the sine of the angle opposite that side, and I don't have that anywhere. So I need to solve for A first. So I'm going to use the standard form of the law of cosines, in this case, the one to solve for side length A. A squared equals, and you will have this form, this formula, B squared plus C squared minus 2 times B times C times the cosine of angle A, which is 115 degrees. Plug all of that into your calculator, and then remember to take the square root of both sides, since that is A squared equals the right side. So A is about 21.26 centimeters. Okay. Now, I take that value. Now I can set up the law of sines. 21.26 centimeters over the sine of 115 degrees equals B over the sine of B. So the sine of B equals 15 times the sine of 115 degrees over 21.26 centimeters. Take the inverse sine of both sides. B is about 39.76 degrees. And then angle C is going to be 180 degrees minus A plus B, which is 25.24 degrees. So B, 39.76 degrees, C, 25.24 degrees, and then side length A, 21.26 centimeters. So in this case, I started with the law of cosines, and then I set up the law of sines with my ratios. Could I have finished using the law of cosines to solve for B and C? Absolutely. It's probably a little more work, but it's totally up to you. So go ahead and try example 4. Once you're done, and then make sure to try example 2 up here. That's basically it for the law of cosines. So now, given any information about about an oblique triangle, we should be able to solve for all the remaining information. So next unit is going to be finding the area of oblique triangles, which we've kind of touched on, and then all kinds of applications of the law of sines, law of cosines, and area formulas. So good. This video is about 10 minutes. I did try to keep this short. Write down any questions you have. Come to class with them if you want to explore this more and really see where the law of cosines comes from. Come talk to me. I love those kinds of conversations. So for now, have a great day. Thank you so much.